Okay, so in this problem, we're told a diver shined a flashlight upward from beneath the water at a 38.5-degree angle to the vertical. At what angle does the light leave the water? So the first thing you always want to do is draw what's going on. So we can imagine this right here is our diver. We know that they're going to be shining this light right here. And we know it's going to be 38.5 degrees to the vertical. And so when we say the vertical, we're just talking perpendicular to our surface here, right, the water. And so we know it's 38.5 degrees from that. And then it's going to leave the water at some new angle, right, as a result of Snell's law, at some new angle theta. And so that's what we're trying to find theta right here. And so notice that we're shining it in water and it's going to go from air. So as I said before, we're going to use Snell's law to solve this, but there's a few things that you're going to need to know. The first thing you're going to need to know is this value n. And n is the index of refraction, which basically relates how much light bends in a certain medium. So in this case, water, in this case, air. And so it's different for each type of fluid. For water, the value is 1.33. And then for air, you need to know that it's equal to 1. So it's different for each type of fluid here. Everyone has a different value, so just keep that in mind. But since we're using water and air, you're just going to need to know those. The next thing you're going to need to know is Snell's law, which is this formula here. N1 times the sine of theta 1 equals N2 sine of theta 2. So let me fix that a bit. And yeah, so basically what Snell's law does, it predicts how a ray of light is going to change from one medium to another. And so we can relate them by choosing this. So 1 is going to represent your initial, right, where it comes from. So this would be 1. So the water, N1, and then your air would be N2, where it leaves. So as I said before, N is the index of refraction. So N1, since we're starting in water, it would be the index of refraction of water, which was right here. N2 would obviously be where it's leaving. And then what is theta 1 and theta 2? So theta 1 is your angle of incidence, which is basically the angle to the vertical. So in this case, 38.5 degrees, right? So the ray of light, the angle to the perpendicular of your surface. And then N2 is your angle of reflection, which is where it leaves, right? But the angle to the vertical again. And so what they want us to do is we're solving for the theta where it leaves, your angle of reflection. So this is your theta 2. And so that's what we're going to be solving for here. So in this formula, we're going to need to know N1, theta 1, and N2. And that'll just leave theta 2, which is what we want to solve for. And yeah, so it's just simple plugging it in now that we know everything. So as I said before, N1 was 1.33. Then we have the sine of theta. So theta 1 angle of incidence, which is 38.5. So this right here is going to be equal to N2. Right, N2 is where it's leaving. For air, the value is just 1. So you really have the sine of theta 2. To get rid of the sine on this side, what you would do is take the arc sine of both sides. So theta 2 equals the arc sine. I'll just do it like this. So we're taking the arc sine of 1.33 sine of 38.5. So what you want to do is take out your calculators. Let's see what this value is. So 1.33 sine of 38.5. And then you're just going to take the arc sine of that value. Yeah, so you're going to get your theta 2. Let me write this a bit better. Theta 2 equals 55.89. So you can round whoever you'd like. I'm just going to say 56 degrees. So just make sure you round how your teacher would like you to. I'm just going to round to the full number just to make it a bit easier. But your angle, 56 degrees, your angle of reflection, right here, your theta 2. So when they ask, at what angle does the light leave the water? Well, it's leaving at an angle of 56 degrees, about. And yeah, so all you got to know here is Snell's law. That's just the main takeaway from this problem. And then determining what your index, right, these n values are, and then recognizing the angles, right? So angle of incidence, angle of reflection, and then it's just a matter of plugging it in. So this right here is going to go ahead and be your answer. And hopefully you found this video useful.